Hi, my name is Jesseline, and this is going to be a video over permutations and combinations. So let's go over some vocabulary first. We need to know what a factorial is. A factorial is the multiplication of that number by even smaller numbers down to 1. So for example, if I have 4 factorial, and factorial looks like an exclamation point, this means that I do 4 times 3 times 2 times 1. So I do everything that's lower than 4 and I just continue to multiply by that number until I get to 1. So like 25 factorial would be 25 times 24 times 23 times 22 all the way down until you got to 1. Really big number. But 4 factorial, 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. So 4 factorial is actually easy to do even in your head. So 4 factorial means 24. The next thing we want to talk about is permutation. So permutation is an arrangement of n objects in a specific order using r objects at a time. So order matters in a permutation. So if you're doing something and you're trying to find the combinations of everything, but order matters, then it's called a permutation and not a combination. So the formula for permutations is n factorial all over n minus r factorial. So for n objects in a specific order using r objects. So this is the formula for permutation. So if you're taking notes, you can go ahead and write that down. So n factorial all over n minus r factorial. And then a combination is where order does not matter. It's a selection of r objects from n objects without regard to order. So combination NCR equals n factorial over n minus r factorial and then r factorial. So if you notice, this is a very similar formula. It just has the r factorial down at the bottom as well. So this is combinations where order does not matter. So for example, on number 1, it says a news program has time to present 2 of 4 available news stories. How many ways can the evening news be set up? So order matters here because we can't repeat our news stories, and they want to do 2 out of 4. So they have 4, they've got to choose 2. So they have 4, so since order does matter, it's a permutation. They have 4, they're going to choose 2. So they have 4, they're going to choose 2. Remember the permutation, I'm going to write it, was n factorial over n minus r factorial. So remember, this is n, this is r. So we'll plug 4n for n and 2n for r. So 4 factorial over 4 minus 2 factorial. So now we're going to solve this. If you remember what 4 factorial is, remember 4 factorial is 4 times 3 times 2 times 1. And then 4 minus 2 is 2, so 2 factorial. So 2 factorial is just 2 times 1. So I have that, and now I can just, 2 and 2 will cancel each other out because 2 divided by 2 is just 1. And then 1 will cancel each other out. And now I can just solve it. So 4 times 3 is 12. That's all I have left on top, and I have nothing left on bottom. So my answer is just 12. So there's 12 ways they can choose 2 stories out of 4. Okay? Another example is T, V, and W taken 2 at a time. So we have the letters T, V, and W, and we want to see the combinations of the pairs that we can get taken 2 at a time. Order doesn't matter here. So because T, V, and VT are 2 different things. So order doesn't matter, taken 2 at a time. So this combination, 3, choose 2. So we have n factorial over n minus r factorial all over r factorial. So remember, this is our n, this is our r. So 3 factorial over 3 minus 2 factorial over 2 factorial. So we're going to solve this. Okay, so we have this. So 3 factorial is 3 times 2 times 1. 3 minus 2 is 1 factorial, so that's just 1. And then 2 factorial is 2 times 1. So I'm going to cancel out what I can. Can cancel out these 2's and 2's, 1 and 1, and see what I have left on top. I have left on top is 3, and what I have on bottom is 1, but anything over 1 is just itself, so I can just leave it. So 3. I have 3 chances of taking 2 at a time, where order does not matter. Okay, let's talk about a tree diagram. A tree diagram systematically lists all possible ways of sequence events that can occur. So the advantage of a tree diagram is a visual display of sequential events. But the disadvantage is it's only practicable if you have a number of choices that are small. Okay, so it's not easy if you have a big number. So for example, flipping a coin 3 times. If you flip a coin 3 times, the first time you can get a heads or a tails. Okay, so that's the beginning of our tree. Let's say I roll a heads the first time. The second time, now I can still roll a heads or a tails, right? Let's say I roll a tails the first time. The second time, I can roll a heads or a tails. Okay, now let's say I roll heads and then a heads. The third time, I can still roll a heads or a tails. So if I roll a heads or a tails, I can still roll a heads or a tails the third time. If I roll a tails and a heads, then the third time I can still roll a tails or a heads. And then if I roll a tails the first time, a tails the second time, the third time I still have a chance of rolling a heads or a tails. So this tree right here gives me all the combinations. So here's how you read it. Heads, heads, heads. You just go down the branches. Heads, heads, tails, and I'm gonna write them. So heads, heads, heads. Heads, heads, tails, heads, tails, heads, heads, tails, heads, heads, tails, tails, heads, tails, tails. That's all of that one. Yeah, and so now this one, tails, heads, heads. So tails, heads, heads, tails, heads, tails, tails, heads, tails, 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 heads, tails, tails, heads, and tails, tails, tails. Okay, tails, tails, tails. So those are all my combinations. And if you count the bottom, 1, 2, 3, 4, 5, 6, 7, 8, that's how many combinations you should have. So then I say, well, what's the probability of rolling 2 heads and 1 tail? So I circle everything that has 2 heads and 1 tail. 2 heads and 1 tail. I think that's it. So in this case, it would be 3 out of 8. 2 heads and 1 tail, 3 out of 8. Okay, that is a tree diagram. Thank you for watching.